everything that you're seeing now should be twisting your minds, because it's taking the things, it's almost like you spend so much time on one thing throughout all your math education. You spend so much time gearing up to do calculus. And then you get to calculus, and then everything's on the real numbers. And then all of a sudden now you're told, hey, all those things you could do on the reals, you can do them with matrices, you can do them. So you're getting all of this at once, especially if you're in the linear algebra class right now. You're probably getting it from every side, some weird stuff happening all at once. But it is really cool. You can't deny you have a teacher who's passionate about the topic. It is really, really cool that it all breaks down like this. So I wanted to start out with this example because Don was asking about it, just to give you like more examples in there. This is the notation we have for the polynomials of degree 3, or it's actually 3 or less, but we just call it P3, because as you noted the other day, the A0, A1, A2, and A3 can be changed so that you can put any polynomial in there. The 0 polynomials in there because I can just set all those coefficients to 0. Constant polynomials in there. 0 is a constant, but just if I wanted another constant, I could put in a constant and set all the other ones to 0. It's a vector space. It satisfies all those checkboxes I gave you. That you do not want to lose, because you'll need to, I think I give you something to prove that it's a, ask you whether it's a vector space or not. So you literally have to go through the checklist and see if it's worthwhile to do one grueling checklist proof. Even though I don't like them myself, it's good to do that. So P3 is a vector space, and a vector is a polynomial of degree 3. Or less, with real coefficients. So when I printed this for you, I try to, I animate them, because I've realized over time that if I have just a bunch of stuff coming at, it's just so hard to see it. So I don't know if I've missed anything on those printouts, because I got rid of the animation. Does this clarify it a little bit more? So all that stuff you did in 205 or 255, all works in this space too, with those polynomials as being vectors. The next question should be, well, I did some stuff with magnitudes, and I also did some stuff with orthogonality. They spent a lot of time on that in 205, 255. Actually, 255, they don't spend a lot of time on anything. You've got breakneck speed. I don't know who decided that was a good thing, but 205, you should be spending some time on it. Okay, I gave you this other example, little L2 of R. That's the space of the entire sequence are the vectors, where those things are real numbers. And that square sum converges. So I told you the other day, that's an element of, so one of the things like, going back to set theory, it was kind of fun to look at the Brown Bombers, because I could see when you took notes that you were trying to understand this. But every time you have a set, you have to understand what's in that set. What are the objects in that set? What do they look like? So how do I belong to that set? To belong to that set, you must be an entire sequence. Every element in that set is a sequence. And those sequences must be square summable. And that's because the sequence of partial sums converges. If you are taking notes inside a iPad or some other device, you can send me those notes and I will print them for you. Same goes with any assignment. You can always send it to me and I'll print it for you. A vector is that entire sequence. What's an example? Sometimes when I get complicated sets, I think about what's in the set and what's not in the set. here's an example of something that's not in the set. Well, that's because when I square it, those partial sums do not converge. How much time do you guys spend with this in your 205, 255 course? Okay. Let me see. I think in your handouts, I didn't put it in the, let me see if I found it. I spend, when I'm in calculus at another college, I spend a whole month on sequence and series and Taylor series. 1 month. And I start off the semester with that. I start off, because it's the hardest thing to understand. And if you push it towards the end of the semester, then no one's going to listen. Everybody's got other classes going. And my former college, they talk about how busy you are. My former college, I had students that had children. I had students that were taking care of aging parents, worked full time. And so people were really busy. And so if I waited till the end of the semester, I don't have their attention because they're going to have all the pressure coming from other classes. So I rotated it around. And the one thing that I kept seeing after I left those courses was sequences and series. You need it, absolutely needed it. Can't skip it. So it's an abomination to spend 1 day on something like this. In your notes, apparently I don't know what happened, but in your notes you should have proof that this is in your calc book. That's why the calc book is so heavy and expensive. They have all the theory in there, and they also have like the blue boxes that tell you what to do. But if you look in there, the definition of series is actually the partial sums converge. This is not Stewart. All calc books are the same. I don't know why we spend so much time talking about calc books. They're all the same. If you go look at any calc book, they have exactly the same material. And it's defined as partial sums converge. Partial sums are sequences. So when you guys talk about series, I'm like, they're the same as sequences. They're exactly the same. They're not different. So I just wanted to show you that the harmonic series diverges.